Okay, so this lesson is about integrating with u-Substitution. So you're going to see that you start with something that's clearly a lot longer than what you're used to, but I wanted you to see where it comes from. So I have the answer over here. So this is what happens when you take the derivative of something with the chain rule. So I have a composite function, I have f of g of x. So if I took the derivative of this, I have both an inside function, g of x, and an outside function, f. So when you take the derivative, you do derivative of the outside, f prime, leave the inside alone, g of x, times derivative of the inside, g prime of x. And you can see that that's what this is. So we are undoing that. So if we undo this, which is longer, we get something that's shorter and more compact. Now remember, when you take a derivative, you have to do times g prime of x times your u prime, and here it sits. So when we undo this, this part will go away. All right, now another way that this could be written is we have just instead of f prime, we just have f because you're just integrating a function. So this is often how you see it, and you'll see that it looks the same, but then this mysterious capital F shows up. And that's because we don't really have a symbol for an antiderivative of a function. So it's not like I had an f prime and I could remove the prime. I can't do that. So when they do that, there will be a statement like this one. It says, if f, capital F, is the antiderivative of little f. So they'll put that in its place so that you know, oh, I'm doing an antiderivative. But it's still the chain rule if I go this direction. So it's derivative of the outside. So the derivative of capital F would be little f. Leave the inside alone times the derivative of the inside. So you'd have a times g prime of x. So important things to note here is that when you do this, you're still working with an inside and an outside function. Now, the answer should be more compact than what you started with, because to take a derivative, you get a times u prime. So undoing it, that's going to go away, right? So here are the rules for integrating, the rules, the steps. But the first thing you're going to do is choose a substitution, and that will be your inside function. It says choose the inner part, and it's u equals g of x. So we're just going to write u equals. It might be something raised to the power, or it could be something inside of a trig function, anything like that. Then the next thing you're going to do is calculate du, which is the derivative of g times dx. So when I do this, it's actually what we used to do is du dx or u prime. But if we have du dx here, I can just multiply both sides by the dx. And you're going to see me do that in the first couple of examples, and then I will start writing it out just like this. Then it says rewrite the integral in terms of the variable u and du. We are substituting. So we are removing all of the x's and the dx, and we're putting in u's and du's. So it's a two-part substitution, and I'm going to keep it in two parts for a while until you see the pattern. Then you will evaluate the resulting integral in terms of u. So you're just going to take the antiderivative. So that's either using the power rule or any of the integrals off of your reference sheet. Very last step, you've taken the integral and you've put I'm going to put it right here, plus c. And then you'll go replace the u with what it's actually equal to, and then you have the antiderivative. So those are the steps for u-Substitution. The only thing I would add here probably is that if there's a coefficient you can pull outside of the integral, you should do that first. So you'll see me first find my u, then find my du. Then I'm going to rewrite my integral, and I'm going to pull the coefficients out, and then I will write the u piece in the front, and then I'm going to do it in a two-part substitution. So after I do that first part, I'm going to write everything left in my integral. And then I'm going to do the second part of the substitution to get my du in. So I will take care of the u part first and then the du part second. Once I've done that, I will find the antiderivative, I'll find the integral, I will put a plus c, and then at the very end, I will put my u back in. And that is it.